The next thing we want to talk about with transforming graphs is the idea of a reflections, and these are when you have those mirror images. We have two types of reflections to talk about, the x-axis reflections and the y-axis reflections. An x-axis is when you have a piece of a graph and it flips over it like this, so it would become the dotted line, and that's when you put a negative outside the f of x. Remember when we talked about function notation last time, we said x is your independent and f of x is your dependent. X-axis reflections are reflecting the dependent variable, that f of x or the y. So we say negative f of x, the output. A reflection across the y, on the other hand, says you take an arm and then it becomes this dotted line. You're only changing the x variable or the independent variable. So we'll take the opposite inside with the x. We want to go ahead and try a couple of these together. So given an original function, something like here in part A, write out the reflections about the x and y axis, and then we'll graph them to check it. So f of x equals x minus 3 quantity squared. Reflection in the x-axis, take the opposite of the entire function. So we'll put a negative out in front. So negative f of x would equal negative quantity, x minus 3 squared. It's outside of that. Whereas if you were to do the y reflection, this is where you replace every x with a negative x or an opposite of x. So f of negative x equals, and plug it in right there, negative x minus 3 quantity squared. So just two more to make sure we understand this. And we'll check these on our calculators. Reflection, the x-axis means take the opposite of everything. So negative f of x would become opposite x plus 1 cubed. And reflection in the y would be f of negative x. Replace this with a negative x 1 cubed. Again, x's are on the outside, x-axis reflection, y-axis on the inside. Now, let's check what this looks like on our calculator. Y equals, and then we have x plus 1 quantity cubed as our original. So make that bold. The first reflection we see has a negative on the outside. So the original bold. And then this one here. If we were to place our pen, we have flipped from the top to the bottom and from the bottom to the top. A nice reflection. Reflection in the y-axis, if we were to change where that negative falls, so parentheses negative, here's the original, and then it's flipping across this guy right here. So it's coming right to left and left to right. A little bit different in our shape, and that helps us to see the difference there between our x and our y. Let's do one more. Reflection in the x, reflection in the y. So x is the opposite of everything. Negative on the outside of your entire function. Reflection about y is just changing the x variable. So we'd actually have a negative negative x or a positive x minus 1. Again, to check this on our calculators, so here's our original function that we're given in part B, and then here is our negative on the outside, so our x-axis reflection. Good. And then this one will change where that x falls. We said that for the y-axis, this becomes actually a positive x minus 1, so original, and y-axis. So for our reflections, outsides versus insides.